Welcome back to MegaRise. More than a century ago, if a ship wanted to travel from New York to San Francisco, it had to spend over 2 months at sea, navigating one of the most dangerous waters on Earth, Cape Horn. Not because of a lack of technology, but because there was no other way. The problem was not the ship. The problem was the map. Between the Atlantic and the Pacific lay a strip of land so narrow that a single right decision could shorten global sea routes by thousands of kilometers. But one wrong decision would cost tens of thousands of lives and become a historic failure. The Panama Canal was born from that dilemma. It was never a question of speed. It was a question of whether humanity dared to interfere with the natural structure of the world itself. And when this project was finally completed, it didn't just change how ships move, it changed how global power is arranged. This is the story of the Panama Canal, a place where engineering, geography, and human ambition collided in a way the world had never seen before. Let's explore it together. The idea of building a waterway cutting through Central America appeared as early as the 16th century, shortly after Europeans first set foot in this region. But it was not until the late 19th century that humanity truly attempted to turn that idea into reality. The French were the first to try, led by Ferdinand de Lesseps, the engineer who had triumphed with the Suez Canal. But Panama was not Suez. Dense jungles, relentless rainfall, and a complex river system quickly turned the project into a disaster. Tens of thousands of workers died from malaria, yellow fever, and industrial accidents. The technology of the time was simply not capable of controlling the brutal natural forces of this land. The French project collapsed, leaving behind abandoned construction sites and a painfully expensive lesson. Their failure was not due to a lack of determination, but to underestimating nature and overestimating past experience. Panama revealed a fundamental truth. A great engineering project cannot be copied from somewhere else. It must be designed specifically for the land it inhabits. When the United States took over the project in the early 20th century, they brought more than financial power and engineering expertise. They brought an entirely new way of thinking. Instead of forcing a sea-level canal through Panama, the U.S. chose a lock-based canal system, a decision that changed everything. This approach allows ships to be raised and lowered step by step, overcoming Panama's uneven terrain without excavating the entire route to sea level. It was a fusion of construction engineering, mechanical systems, and water management on a scale the world had never seen before. The lock system was not the fastest solution. It was the most sustainable one. Rather than overpowering the landscape, the Americans chose to work with it. And that choice is precisely why the Panama Canal has endured for more than a century. From an engineering standpoint, the Panama Canal was one of the most complex structures humanity had ever attempted to build at the time. Millions of cubic meters of earth and rock had to be excavated and relocated. Mountains were cut down. The Chagres River, one of the most unpredictable rivers in the region, was tamed through a system of dams and artificial lakes, giving birth to Gatun Lake, once the largest man-made lake in the world. The canal's lock system functions like gigantic water elevators. Each ship passing through must be raised and lowered in stages, with hundreds of millions of liters of freshwater released during a single transit. What makes this system remarkable is that, for decades, it operated almost entirely through mechanical engineering, with minimal reliance on modern electronics. Steel gates weighing hundreds of tons open and close with centimeter-level precision, powered by extraordinarily refined mechanical design. In a world increasingly dependent on software and microchips, the mechanical heart of the Panama Canal serves as a rare reminder. Sometimes, the most durable solutions are the simplest ones. This is not outdated technology. It is technology designed with one uncompromising rule: failure is not an option. The Panama Canal is not merely large in scale. It is the embodiment of a philosophy that seeks to build for centuries of survival, a philosophy that very few modern megaprojects still dare to pursue. As the world entered the 21st century, the Panama Canal faced a new kind of challenge. Ships were growing larger, while global trade refused to slow down. Without adaptation, the waterway that once shaped global commerce risked being left behind. The expansion project completed in 2016 was the answer to that dilemma. The construction of the Neo-Panamax locks made it possible for massive cargo vessels to pass through, while integrating a water reuse system, a critical innovation for a canal that depends entirely on rainfall. But this was not simply a matter of building bigger. Panama modernized its entire control and safety infrastructure, transforming a century-old engineering marvel into a hybrid system, part classical, part modern. This was not a race for size. It was a strategic decision to protect relevance in a fiercely competitive world, one where engineering serves strategy, not the other way around. To viewers, the sight of a massive ship seemingly climbing a mountain across a continent may appear effortless. But behind that simplicity lies a chain of operations executed with absolute precision, where even the smallest deviation can paralyze the entire route. Every vessel passing through the canal is guided by highly experienced pilots. Speed, position, and clearance are tightly controlled, while water from Gatun Lake is released in a carefully calculated sequence, lifting and lowering ships through gravity alone, without flashy machinery or brute force. Every day, hundreds of vessels carrying energy, food, and goods for the world move quietly through this corridor. A single day of disruption can cause billions of dollars in losses, revealing that the Panama Canal is not just an engineering structure, it is a vital artery of the global economy. Looking back through history, Panama has never been merely concrete, steel, and water. It is a story of strategy, power, and the ability to control routes upon which the world depends. And to this day, the canal still stands, silent yet decisive, proving that infrastructure can shape the fate of an entire planet. Panama reveals a simple but unforgiving truth. In the modern world, power does not come only from armies or resources, but from the ability to control flow. And this canal is where the flow of the world is bent. Which megastructure should MegaRise analyze next?